Hello, 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 and welcome back. Today we're going to talk about another proof technique that is proof by contradiction. And here I have a paragraph written out about what proof by contradiction does. So in proof by contradiction, we assume that a statement is false, find something that went wrong, we do some math until something goes wrong, and then once it does go wrong, we can say, oh, I guess we were silly, assuming that was false, so therefore it must have been true. So particularly, how to do that for P implies Q? Well, the opposite of P implies Q, the negative of this is, first off, let's see here, so note that the negative of this, P implies Q, well, this is false exactly when Q, the conclusion, is false, even though P, the hypothesis, is true. So we instead say not P implies Q is the same thing, or is logically equivalent to P and not Q. So if you remember our notation from the first day that we were starting to talk about proofs, we say an implication is false exactly when P is true and Q is false. Alright, so essentially let's go ahead and do an example so we can practice this. Alright, so let's take a look at this claim that says that if x and y are integers, then x squared cannot possibly equal 4y plus 3. Alright, another way to look at this, to say this claim, is that there's no square that is 3 more than a multiple of 4. Which is kind of a neat result and hard to just see straight off the bat. So let's think about how we're going to do this. So I'll leave some space in case we need to do some scratch work partway through. But let's at least start the proof. So let x and y be integers. Alright, so we want to assume P is true. Such that, or let's not say such that, okay. So we want to assume P is true, then we want to assume Q is false. Okay, so the way we want to do that is we want to say, assume toward contradiction, because we want to keep the reader informed with what we're doing and we're not just making stuff up, contradiction, that x squared equals 4y plus 3. Alright, I want to highlight toward contradiction. It's essential to put that in any contradiction proof, because otherwise the reader doesn't know what's going on and is starting to assume that you're assuming weird things and gets very confused. Alright, so x and y are integers. We've assumed that x squared equals 4y plus 3. So look at what we notice. So what that means is that 4y plus 3 is odd, right? We're taking an even number, adding an odd number. So x squared is also odd. Okay. Now, in your pre-class, what you're going to do is you're going to prove that if x squared is odd, then x is odd. So by the pre-class, assignment, this means x is odd, so what can we do with an odd number? Well, we can write it so that it's very explicitly odd. So we can write x as equaling 2 times n plus 1, where n is some integer. This is one way to write any odd number, which you probably saw in calculus when you're doing series. Alright, so let's think about, so let's just do some scratch work and think about what x squared is going to look like. So x equals 2n plus 1, and x squared then is 2n plus 1 squared, which if we FOIL that out, we get 4n squared plus 4n plus 1. Right? So let's say down in our proof, all right, then we get 4y plus 3 equals x squared equals 2n plus 1 squared equals 4n squared plus 4n plus 1 via substitution. Again, at every point we're keeping the reader informed of what we're doing. We're not just making stuff up. We're following logical steps. Alrighty, so let's look at this now. So we have a multiple of 4 here, a multiple of 4 here, here, and then we have 3 and we have 1. Okay, let's think about that for a minute. So that means that on the left side it's 3 more than a multiple of 4, whereas on the right side it's only 1 more than a multiple of 4. So if we write that out explicitly, rearranging, we find, right, so let's move all the 4 stuff to one side, 4y minus 4n squared minus 4n equals -2, right? And in fact, let's just factor that 4 out. 4 times y minus n squared minus n equals -2. And my phone dinged. It's all right. Let's keep going. Look at this real quick. Y was an integer, n was an integer, so this whole thing is an integer. Okay. So now what we're saying is that -2 is 4 times an integer. Does that even make any sense? It shouldn't. So, however, y minus n squared minus n must also be an integer. Alright, so let's give this an equation a name because we're going to refer to it. However, that must be an integer. So equation star indicates that -2 is divisible by 4. This is definitely not true. False. Sorry, I was doing 2 things in my head. So this is definitely false. So, we have arrived at a contradiction. All right, boom, let's put an exclamation point because we're very excited about this. We've gotten to the point where we know for certain that the statement's true because it's clearly incorrect if you assume it's false. All right, if that makes any sense. One thing I like to do after I've found a contradiction is I like to put a lightning bolt. Be like, ha, take that, math. Okay, anyway, so therefore, the original claim is true, which is if x and y are integers, then x squared cannot possibly equal 4 times y plus 3. And we are done. All right, excellent. So I'll zoom out so you can see the whole proof again. And just a few things to remind you. It doesn't ever hurt to do some scratch work, even partway through a proof. There's no reason that you need to know the proof from the beginning to the end when you start, right? The second thing is when you're doing a proof toward contradiction, you want to make sure the reader knows, so we highlighted that. And you kind of just want to do stuff until something goes wrong. If you did some extra stuff that you didn't have to do, you can always go back and erase it. And yeah, lastly, just keep the reader informed. Let them know at the end once you found the contradiction. Let them know where it is and how it worked and how you got there. All right. Excellent. Okay, we'll stop that there. Have a good one.